everyone, welcome back to our channel. In this video, we'll study about the charge to the mass ratio of electron and mass of the electron. Okay. In our last video, we have studied about the discovery of electron and the charge of the electron. Means, in the last video, what we got to know that electrons are negatively charged. But in this video, we'll come to know the exact value of the charge of electron. Okay, that is by the charge to mass ratio of electron experiment. Okay, this charge to mass ratio of electron is measured by the scientist called J.J. Thomson in the year 1897. This is measured by J.J. Thomson in the year 1897. Okay. J.J. Thomson did the charge to mass ratio of electron calculation. Okay. Here, this is the experimental setup of calculating the charge to mass ratio. This is what we have seen in our last video to know the charge of the electron. Okay. This is the glass tube and these two are the electrodes. This is cathode electrode and this is anode electrode, which are connected to the high voltage supply. And here it is the electric plates. These are the electric plates and this is the magnet. These electric plates are used to apply the electric field and this magnet is used to give the magnetic field. Okay. And what we have seen in the last class, those are whenever we apply the high voltage, the electron starts moving from cathode to anode. Okay. These are the rays of electrons. When only electric field is applied, then the electrons start moving in this direction. Okay. So only when magnetic field is applied, the electrons deflect in this direction, that to C direction. But when both electric and magnetic fields are not applied or when they are in the same amount, then they show the straight line position. Means they travel in a straight line. Okay. These are the observations what we know. Okay. Now what he did, Thomson, what he did is he told that the amount or the extent of the deviation of these path of electrons, it depends on the strength of electric and magnetic fields. Okay. Here what he did, he applied both electric and magnetic fields perpendicular to the path of the electrons. Perpendicular means in like this. Here both electric and magnetic fields are perpendicular to each other. Perpendicular, that is, those are 90 degrees to each other. That is called as perpendicular direction. Here he applied both at the same time in the perpendicular direction. Okay. And he said that first one is, he said the amount of deflection depends on the nature or the strength of the negative charge applied. Okay. Strength, or you can say magnitude of the negative charge. First one is magnitude of negative charge. Okay, how this magnitude of negative charge affects the deviation of this electrons? Okay, we'll see. As the greater the magnitude of the negative charge will increase the interaction between the electrons, so which increases the deflection. This is what he says. Magnitude of negative charge. Negative charge means here the negative charge is traveling. Right here the electrons are traveling from cathode to anode. Okay. If the magnitude or the amount of negative charge is more, then obviously the deflecting electrons will be more. Right. If they are in less number, then the deflecting electrons are also less in number. So this is what it says. Magnitude of if the magnitude of negative charge is more, then obviously the deflection will be more. This is his first observation. And the second one, he tells about the mass of the electron. Mass of electrons or particles. Okay, what it says is, if the particles are lighter in their mass, then they deflect in a faster way, means faster rate. If they are heavier in their mass, then their deflection will be in slower rate. You can say, for example, you take two stones, one is of 5 grams, two stones, this is of 5 gram and this one is big one. You take another one here, this is of 500 grams. Okay, you have taken two stones, one is of 5 gram and another one is of 500 grams. And if you throw them with the same speed, then which one will go in a faster rate, means which one will move very forward? Obviously the one which is of 5 gram, means the one which is lighter in its mass, it will travel in a faster rate. Like that only here also, particles, if the particles are in less mass, if they are lighter in mass, they travel in a faster rate and hence deflection will be in a faster rate. If the particles are heavy, then deflection is very slow. Okay, this is the second observation. And the third one is strength of magnetic and electric fields. Strength of electric and magnetic fields. Here he has applied both electric and magnetic field. Now he tells about the strength of electric and magnetic fields. If the strength of the electric and magnetic field increases, then what he tells, obviously the deflection or the deviation will be increases. Means if the applying voltage, here you take this electric field, okay, these are connected to the electric supply. Okay, if we apply here high voltage, then the electric field will be high, then deflection will be more towards in this direction, right? So if the magnetic field is more, then the deflection is more towards in this direction. So obviously if we increase the strength of both electric and magnetic fields, then we'll see the more deflection or deviation. Okay, by still further studies on this experiment, he gave one charge to mass ratio value, that is 1.758820 into 10 to the power 11 coulomb per kg. Okay, that is E by me, it is equal to 1.75 this is the charge to mass ratio value given by the J.J. Thomson. Okay, that is 1.758820 into 10 to the power 11 coulomb per kg. Here E is charge of the electron. Okay, this is how we represent electron, right? And then Me is mass of the electron. Mass of the electron. E, that is charge to mass ratio, that comes out to be 1.758820 into 10 to the power 11 coulomb per kg. Here mass will be in charge will be in coulombs and mass will be in kg. So that is unit is coulomb per kg. Okay, this is about the charge to mass ratio of electron given by the scientist J.J. Thomson. Now we'll see the charge and mass of the electron. After the J.J. Thomson, another scientist came. His name is Millikan. Okay, Millikan did the experiment called as oil drop experiment. That is famously known as Millikan's oil drop method. Millikan's oil drop method. With this oil drop method, he exactly gave the value of charge of the electron. Okay, what he gave? He gave the exact value of charge of the electron. That is, charge of the electron is 1.6022 into 10 to the power minus 19 coulombs. this is what the value of the charge of electron given by Millikan. Okay, with the help of this E and E by ME ratio, that is with the help of the works done by Millikan and J.J. Thomson, we'll get to know about the charge, that is mass of the electron. Okay, we know that is E is 1.6022 into 10 to the power minus 19 coulombs, and the value of E by ME is 1.758820 into 10 to the power 11 coulomb per kg. Right. If we now what we know, what we want the mass of the electron. So it is simply E divided by E by ME. If we do this, if we calculate these values in this formula, then we will get to know the mass of the electron. That is E is 1.6022 into 10 to the power minus 19 coulombs. Okay, that is divided by E by ME is 1.758820 into 10 to the power 11 coulomb per kg. This is what the mass of electron. If we substitute these values, we'll get to this value. Okay, this is the mass of the electron. And what is the charge of electron? Charge of electron is given by Millikan by his oil drop method, that is 1.6022 into 10 to the power minus 19 coulombs. This is the charge of electron. And what is mass of electron? That is 9.10 into 10 to the power minus 31 kg. Okay. At the end, what we got to know? We got to know about the charge of the electron and mass of the electron. Okay, this is all what we have learned in today's video. Okay. If you have any doubts, you can ask me in the comment section. Have a nice day. Bye.